Okay, hello everybody, so we are back. So today is the second part about IO, well, this time it's IO bound, workloads and tuning, and well, the main change. So in this case you will have now, so all problems which we saw for CPU bound in memory, so it's still again valid. And now we have IO reads. So means you will use storage a lot. So and that's why your storages will be a masterpiece of everything, because well, it's slow. Everything is slow. You cannot speed up your storage. And since you will need to read, you cannot speed up reads. Especially if it's OLTP, so it's totally random. You're totally relying on storage. But not only this. So your fsync will be always critical for review log, because except you keep data and it will just scan it, so it's one story, but generally do some changes. So it's always relied on read log latency. And also, if you read, so generally you will not have enough of one drive, so you'll have many. So if you do read 5, read 0 plus 1, or 1 plus 0, so think about stripe size, because this will impact directly your double write. So double write is a small file. So if you'll write, if your chunk is stripe chunk is big, you will only write to one device, not to all others, and you will go with speed of one device even if you have 10. Okay. The other points are also critical for you. So. Linux kernel, pay attention, there was many regression, so you may be just not aware, and all your problems because of this. File systems the same, so we saw many in the past. So XFS in x64, it's most popular. XFS is most advanced, so you can have a bigger storage on this one. So some people trying to use ZFS because you have nice security, compression, and so on. But you need to really be expert inside. You need to configure it right and so on. The only problem then at the end, people, what they're saying, then you need to recreate your file system from scratch because too much fragmentation. And well, BTRFS, some people want to use on your own risk. So it's, by definition, slow. It's not for database, that's why.
One question?
Yeah.
So the slowdown on the BTR is the copy
It just, no, not only this, because it's not done for parallel activity of database. So as soon as you start something serious, just, nothing slower like this. Okay. So for kernel, it's fine. For RPM, you can do snapshot, come back, and so on. So let's start from nice news from. So it's about regression in the kernel. Yes. Question.
I have a question regarding the previous slide.
Okay.
I'm assuming grade 10 on top of storage.
Yeah.
And this stripe size of 128K, can you, or 256, can you explain why?
Yeah, because your double write will be not bigger than, so in fact, your targets and your double write also dispatch it between all your drives, okay? Otherwise, all your writes and double write go to first device in your read and not on others. So since it's always you write twice, so you will always go in with the first device, not others. So they will not help you. Your read will be, okay? So this regression in the kernel. So we are working with Oracle in Extreme to fix it, and they have potential to fix it. It's amazing, but it looks like it's related to scheduler. So it's hard to imagine, and not only we observed this. So I'm surprised they don't. Only MySQL complained because it's valid for all kernels since 5.15. Any new kernel has this problem. And well, you see for us, the most critical, so it is peak performance. But for many will be probably also critical that you have regression in the high level. So it's not something you will expect, but it's reality. It will be fixed, so again, people pushing these changes to upstream, I hope it will be done. Another topic, so I don't know what to do even here. So right now there is no way to limit file system cache on Linux. And whatever you do, so for some reasons, I observed this several times, So Linux guys don't believe me, it's not possible. Until there was real big customer call it Oracle and say, we have this. So in fact, they have plenty of memory. And for some reason, Linux cannot decide to increase file system cache and move everything Oracle database in swap and so you can imagine. So the only workaround right now is switch swap off, so then nobody can move you on swap, but it's reality. And once you are going on swap, you know that you won't go fast enough. Well, this is about sad news. Now about something more fun. So on IO bound, you can also start, you may have just read only. Like in memory, you have only select. The only difference now, okay, so you will read your data from the storage, from the disk. So this is just, and it's real life example. So you have many data. You have one batch, which is scanning 1 terabyte of data from one database, totally independent. You have another one which also will scan 1 terabyte. So each one is taking 1 hour running alone. How you can you say how many time it will take if we will run them both on the same time? Any idea? 1 hour? 6 minutes. You are not far. So it takes 3 hours. Why? And this is totally different from in memory. Like when everything in memory, okay, you run 2 big queries, it will go fine. What happens here? It's no time to sleep, guys. So the problem is, and both reading from storage, right? So batch 1 will read the data, bring to buffer pool, need 3 pages. We'll remove pages read from the batch 2. Batch 2 doing the same, removing pages which will bring for batch 1. So in fact, both, they will not work together. So they will read more and more and more, and in fact, you have 3 hours. But if you run one after one, you have 2 hours and everybody happy. So well, at least one is happy, finish it in 1. Second will wait for 2 hours. Potential trick possible here. So this is what it was amazing. So since MySQL 8.4, we switched it to direct by default. Okay, so it was also discussion, should we do it by default, or just for dedicated servers, or just default? And we got many cases which were interesting, like some internal test on MySQL started to go slower, some faster, so fine. And we discovered only in some cases when you just run big select queries, using fsync instead of odirect, you can get better performance, but only for select, so you don't do any updates, nothing. So in case when you have a batch which will take 1 hour, what you can do, so you stop MySQL Server, you drop file system cache, you restart with fsync, and then you run your batch, and you will leave file system do prefetch for you. So you saw this morning, so Vitor explained how it's complex to do prefetch right? When you are storing not direct, how you want to read in parallel. File system can do it for you for free. So just it will do or not. So you can test. If it works for you, it's just a kind of workaround. Once you finish your batches, it will be faster than 1 hour. In this case, you restart with odirect, and you're ready for OTP read write. So then you restart on your write, so normal activity. What is complicated in this case? So it's much more complex than what we have with in-memory CPU-bound workloads, because in this case, again, so you want to bring some data from storage, right? You want to bring them to the buffer pool. To put in buffer pool, you need to have a free page. To get a free page, you need to find which pages you can remove. It can be a clean page or just a victim, that's all. It can be a dirty page and you need to flush. So you will need to write. Your storage is limited in number of operations per second. So if you do too much reads, you cannot do writes anymore. You do much writes, you cannot read anymore. So it's all about the balance, about all this stuff which is going. So you have kind of streams, reads, writing, and you're trying to keep a balance. So for writes, writes are most efficient on Linux, especially it's with asynchronous I/O and not direct. With read, so we are using just without asynchronous, just direct reads, and it's intentionally so because any try to use asynchronous, it was disaster. So it's really complicated for even for system to manage this. So and this story can impact file system. So it can your file system can be not ready. In fact, so you have one type of writes, another type of reads, and you have a mix. So in double write, we also have a direct and so on. So in the past, it was the story for ext4. So if you're interested, I have a blog post about. So now it's supposed to be fixed, but well, I can confirm that XFS is doing the best anyway. So if you recall, we discussed about how Flash is working. So these all improvements are historical, so coming to 8.0. And at the end, so we need to manage this LRU flashing. So you have a list of pages at the end, and we have page cleaners, which will be, all their work will be driven by demand of free pages. So every time when you have, it's not like you, they don't care if you miss free page or not, they don't check. So what will happen then, you will have user threads, which will send a signal inside. So in fact, once per second, so we have page cleaners which are waking up, if nothing happens, they will check, then you have amount of free pages equal to LRU depth. So LRU depth is by buffer pool instance, okay? So you don't need to make it too big, so I will show this next. So in fact, sometimes people have tendency to set LRU depths very big. Like I know that I will need, I don't know how, million free pages and I will keep it. It's not, doesn't mean you will have, so probably you just will remove pages and you will lose in performance because you will cache less in your buffer pool. So you can put 1,000, which is by default, and then let page cleaners wake up on every demand and do cleanup for you. Okay. The most interesting what happens for user thread. So user thread will try to get a free page. There is no free page. Okay, it will put signal for page cleaner and try to do several loops. It will wait in loops. Still no free page. If there is no, it will involve single page flash. So single page flash, it was blamed, I don't know how many times. So I think Percona, they wanted to remove it and were happy we remove it. It's not really a nice decision because once users, well, whatever thread, once it has CPU, it should do some useful work, not just waste CPU cycles, okay? So and this is a way to get efficiency. So still better to do nothing. So recently we made experiments. If you just disable single page flash, so the green line is with single page flash, and red and blue without. And even if you disable just single page flash, your MySQL instance will be frozen very quickly. So because page cleaners are doing first, they flash in dirty pages, then they do LRU. And in fact, if you have user set, which will block some data and they cannot flash it, so nobody can resolve it. So in fact, it just user will block the data, then unlock the data, will be able to do single page flash, take some page somewhere, and unlock situation. So the solution is just to have all the threads separated, dirty page flash and LRU flash and totally alone. But well, even in this, the only way to get the same level of performance, you have a lot of threads, which will do flashing and have IO threads, IO write thread. Only this you can keep a piece. But then, what kind of useful work you're doing? Because you also need CPU for your user threads. And this is once again, so it's tuning coming by monitoring, but it's not much you can do here. So first, LRU scan depth, so you can keep it for 1K, so by default, and I say, okay, so hooks and page cleaners will do the job. Or direct is mandatory, so sometimes people use, no, I think it's bad idea, so because you can lose data. You need to have consistent sync. So especially you're on storage, everything you saturate your storage, and you cannot accept, and you will lose. So you may get a crash, for example, or sometimes so it's Facebook reported in the past, like you have errors on the storage, but it's kind of on Linux kernel, it was not reported. So you continue to write, you suppose it's writing, but it's not writing anymore. So change buffer helping always, so especially for secondary indexes on I/O bound. So it will save you some I/O. You will not write secondary index pages at once. It will be delayed. And well, for double write, you will see that you can have different variations. So the current default seems to be good enough for everything, but you may still check what is going on. So probably other defaults for you can be better, especially when storage is saturated. And then you have all in the DB metrics to see, okay, what is demand of free pages, how many you flash, how much you can flash, how many single page flash you are doing. So it gives you an idea about what's going on. The real help on this, better storage. So storage will be always a key piece. So F-data sync, which is new default now, it was new option which was introduced pretty recently. So if you think there is no innovation inside, there is. So I forgot to mention here. So with F-data sync enabled and without, this is a disaster. So it's always critical. So as this F-sync performance, it's always impacting you. Well, except if you don't care about your data, right? So then, okay, your transaction can be 2, let's go, and let's crash it, fine. If you have a backup, okay. Change buffer. So change buffer, you don't hit very big. So just 5% is enough. You just enable to all. And well, especially on high load, it's visible. But just keep in mind that this buffer is change buffer is in your buffer pool. So if you give more memory, so it's less memory you will use. Also, it has direct impact if you want to resize buffer pool dynamically, for example. So this will mean then you decrease buffer pool, you decrease your change buffer, and then change buffer need to flash all the changes you made. You may get performance impact. So you need to, well, in case you resize buffer pool, so you need also decrease your change buffer, so increase or to delay all the separation. Double write impact. So, well, at least here I did not forget. If you forgot about innovation, so it was in 8.0.20 introduced the new buffer pool. Oh, it's buffer, double write. So double write impact, when you're in memory, it's mostly no impact. So in some particular cases, you have an impact on this and so on. Because, well, all page writing is going in background, so you don't care. It's not impacting. What is impacting the user when you have in memory? It's only about latency on read load. So your page flashing is going in background until you are able to follow your charge with read log write and page flashing. You're only impacted by bin log and read log. But when you go to I/O bound, so for I/O bound it's totally different because for every page write, you will write also in double write, and you also read. So in fact, you saturate your storage, and so you can see the red line is a new double write, which totally changes the story. And who made it? The man is not sleeping. Thank you, Sally. But the story is not finished. So new default we have, so with new double write, you can configure number of pages in double write and number of files. So before it was 2 files, 2 pages, or 2 files, 4 pages. New default is 2 files, 128 pages. But when you have saturated storage, you see in this case, green line with small double write, it's helping you get better performance. So in saturated storage is this case. If you don't have storage saturated to its bigger capacity, the story is different. So in this is how you can play with your config. And you cannot say what is better for you. So we just found that, okay, 2 files, 128, it's most good enough for everything. Well, for not saturated storage, but you may have different case. So of course, the biggest solution for us will be once we adopted Atomic I/O. So Oracle Linux team already pushed this forward. So it's already in the kernel. So it should be available for everybody. The only problem I see inside, they need also to have API in the storage. And you see, so during the last years, everybody claimed that all flash storage we have, it's already atomic, because it's not copy and write, it's every write you write a new block, right? So you never rewrite the same cell in flash storage. But if you don't have API, if your storage cannot say, I am able to do atomic I/O, so I don't know, probably it will progress in some way, so you can say just, I know my storage is able to do I/O, I want to use atomic I/O. Let's see. So right now it's defining new standards, and well, I hope everybody will follow, because you can imagine, so you don't use double write anymore, so your flash storage will live twice longer, even you don't have any gain in performance. But well, you can see the red line in both cases, saturated or not saturated. It's better when you have double write. So it's my big hope about this feature. We're working closely with them. And now, this is, well, it's kind of work in progress. It's about, I'm trying to understand, okay, why people complain that if you have more than 1 terabyte of data, so everything will be slow, what kind of problem you may have. So this is kind of, well, it was the most simple to get fast storage, well, 1 VM, which is running Oracle Linux 8, XFS, 16 cores, 256 memory and 8 terabyte of storage. So I could play with 2 terabyte, 4, 6, and so on, and see what will happen. And also change, okay, see how buffer pool will impact or not impact. So change buffer will impact thread pool. We discussed it yesterday. And this all based on sysbench OLTP drives, okay? And also the bold investigation was here, bold point is about InnoDB transparent compression. So there was many improvement made in the Linux kernel to support punch holes. So we wanted to understand, okay, is it really stable now or not? So it was, you see, kind of multi-topics in one investigation. So first of all, it was amazing that whatever you do, after 1,000, just disaster on performance. So you can see only green line and orange line. When we use thread pool, it helps. So we can be stable. So just thread pool is protecting you from dying on high load. So it will just keep you on the same line. But you use binlog, you don't use binlog, you see the difference is very small. So storage is really busy here, and okay, we can do what we want. So up to 1,000 users, we keep the loads, and okay, it's disaster coming. Okay. Now we'll change in buffer pool, we'll change something. It's the same disaster, so we don't need to look on thread pool, not on binlog, but we know, and okay. Using smaller buffer pool, yeah, bigger buffer pool did not help.
Sorry, just to understand, when on this test that you're doing, are you using the variables data fields or all of them fixed size? So whenever you write, there is create, split pages, and so while you write, you increase the number of data that is going to be sparse, or is it going to be always ordered data?
No, because So sysbench OLTP read write, you have write transactions, so it's 4 queries, 2 updates, 1 delete, 1 insert, right? And as soon as you start to do insert, delete, so you already moving data, and one of update is doing index update. And this is always, so if you do only index update, you have a huge impact. So this is, let's say,
Okay, so
reasonable workload. Yes.
Mixing the thing.
It moves a lot of stuff, but okay, it's 14 queries doing select, 4 doing writes, so it's kind of good enough for, let's say, simulation of production. So big surprise on buffer pool size did not change anything, so it's really about storage, you see. 64 or 2, well, it's 200 by default, not helping. And I was, okay, and this is about change buffer. So you can see on change buffer, even 5%, it's red and orange line, this is helps. And bigger buffer pool you have, more it helps. Because with bigger buffer pool, 5% of buffer pool give you more space for change buffer. So this is at least all expected. I don't recall. So initially we did not want to enable change buffer by default. We expected to have some fixes. Now everything was applied, so because on recovery you can have a problem and so on. So now it should be enabled by default. So for sure in 5.7 it will be enabled by default. It will be LTS. So and the next part. So it was all TP write in action, okay? But you see, before you come into having 2 terabytes in your database, you need to load this data, right? So of course we have solution with workload today. We have you can disable regulog, you can disable binlog all together. Just load the data fast. But you cannot do it's always in production. Okay. So what I discovered during these load steps remind me what we were looking 6 years ago with IABench, and this is what was pushed in the past. How they call it? I don't recall the name anymore. But pushed a lot with Mark Elegant. It was his brother working in the company. So they implemented this IABench, and we were not good on this test. Okay. So and this in the past investigation I made, so it's written in Python, so running several Python processes of IABench. One are writing, so open with insert. Another is reading, doing select. And the story is not good, so it looks like this. So when buffer pool is big, so everything is looking fine. It's when we have smaller buffer pool, so more data which we're trying to insert comparing to buffer pool. So you see this red line, so every time it's going down, down, down. So I assume we have smaller buffer pool, and it's going down when we don't have any more free pages in buffer pool, okay? I mostly ported IABench, so on Python, now to use it with sysbench to have the same framework. See, so I don't recall if I told it. So I have benchmark it, so it's public, you can use it. It's based on sysbench, many scripts around, so to have IABench also inside. And I discovered just on this test, what do select? It's very smart, in fact, it's for smart to show like InnoDB is bad. So select is every time we'll read all this data. So do you see in any production, okay, you constantly inject new data, but every time you want to read your data from 10 years ago, what will be the reason? So once you read it, you so second time to read again. So generally in production what happens, you insert new data and you want to analyze the latest one, right? So what was recently, not what it was 10 years ago. And once you read what it was 10 years ago, you don't care anymore, no? You will not reread again and again. So the test was really designed to show that when you inject the data and then you want to read the old data, they will be out of your cache buffer pool and you will be bad. So if you will read the recent data, you are good. But well, no matter. So at that time I discovered we have just B3, which is growing, and we saw then we have reads coming from the storage. So just using partitions was solving this. So in fact, you continue to do insert, you finish one partition portion, you switch to another one, you switch to another one, and you always keep your data, hot data in the buffer pool. So we're just fine. So it's just kind of a workaround here. Well, the current story is slightly different. So first, when you load the data, it looks like this. So it's not, at some point, you don't have free pages anymore, but it still continues to decrease. Why it decrease? Was the big question, why it decrease? Especially if you increase relook size, it still decreases, but you do your job faster. And my big surprise was there is no IO reads. So which will be signed, then your B3 really go to the storage, and you need to reread it again. We don't read anything. So there is, well, kind of mystery right now. But at least, okay, you have first workaround by bigger review log, so it can be temporary. You see you can change it dynamically now. So you can speed up already your load data. So you compare it to this one, it is 2 or 3 times faster, right? And if you use partitions, it's even more fast. So this was just 8 partitions, and you can see then, okay, bigger review log helps, but it's really already from the start, even with small review log, you already have a huge difference. The most interesting was when we move it to transparent page compression. So in the past, it was introduced in 5.7, and the biggest problem was the file system takes a long time when you want to drop a file. So once you started to use punch holes, your file drop, it can take 2 hours, 10 hours, whatever. So if file is big and you want to drop a table, in the DB at some point will just make a signal and crash because system call unlink did not return, right? So over time, there was a patch, there was a contribution, I think, also, about to drop the file in background, so we don't need to wait for unlink. XFS was improved, the kernel was improved, so now it's just in few milliseconds you have a confirmation file was dropped and file will be deleted in background. But even this problem is gone, so we observed several different ones. So sometimes it just hit and slow down for no reason. So everything is going fine, going down. So well, I even did not put graph here because you will see numbers, it's crazy. Or the most surprising was you do some IO writes to file with punch holes, and another file which don't use any punch holes will be impacted. So it just, once you have punch holes writes, everything is slow. If you stop it, it's faster. So I don't know what is relation. So for me, this option is not finalized. So now you can see numbers. So it was 32 threads used in parallel, in 13 in bulk insect with 1,000 rows at time. Every time we enable compression, this is different. It's twice times slower comparing to even normal stuff, or 3 times so. Even everything is good with partitions, always twice slower with compression. We expected the opposite because you compress, you will write less, right? No, it's too complicated. It's complicated inside to do all this stuff. So, well, personally, I will not run production like this, especially if you don't know what to expect now. So, to go in more far, it's about 2 terabyte, 4 terabyte, 6 terabyte. So starting with read log of 16 gigs. So in this case, I have 2 VMs. So 16 cores and 32, just to see, okay, will 32 cores help to see better performance? Like everybody expecting you will have more power, you will do better. So, and this system also has storage with higher I/O capacity. It's a little bit better, but not too much. You see, they are not far one from another one. So it's still about storage, how you, what you can deliver inside, and about also CPU power. It's not the recent CPU, but well, generally already, even if you are in memory, so moving from 16 to 32, you will not have twice higher performance. It's just by definition. With IO, it's even more critical. So again, it's not big, but well, you can see you have variations. The most interesting then, so these 3 lines, 3 colors, blue, red, and green. It's about, so blue it's 2 terabyte, red is 4 terabyte, green is 6 terabyte. Mostly no difference. So it was my surprise also. Okay, normally with bigger size, it should be worse, but it's not worse. Well, we have disaster after 1,000, but well, generally before 1,000 users, it looks okay. So even bigger volume, it's keeping work. So this is 16 gig read-log size. 64, well, little bit better, but still, well, not big difference between data volumes. And 128, the same. So it's more stable, little bit. So on 32 cores, you can see that with 2 terabyte of data, you still have better performance with bigger read-log. But well, no big surprise. Surprise then is coming on this data load. 2 terabyte, 4 terabyte, 6 terabyte. So well, we no reason to look on compression, so compression is bad. But helps a lot. So well, you see 35 hours for 6 terabytes, but if you move to partitions, you see you can go to under 9 hours. So it's different story. With 4 terabytes, minimal time, so 5 hours and half. 2 terabyte and so on. And this is 16 cores. If we go into 32, so it's not more than 9 hours with 6 terabyte, but 7 hours and half. So combining bigger read-log and partitions, we can go to something better, and it's already today. So surprisingly, having change buffer on low data is not really helping. So it's when you have changes of data and so on, and you need to delay secondary indexes, then it's helpful. Well, to finish on something positive, at least. So this is IO bound 1 terabyte TPCC, comparing Amazon and what we were trying to do at least, okay, all this time. So, well, you can see the difference. It's stable because of thread pool, but generally, well, it's exactly the same binary of MySQL we executed on OneCloud, so Oracle Cloud, and on Amazon. And if you recall Tank from the yesterday's slide, so this is about RDS. So RDS, I don't know, it's totally bad on IO. Somebody using it. Well, hope everything clear, more clear for you now. Any questions?